Hi friends, hope you're doing fine. So, as a part of our journey, uh, hybrid cloud RHEL 8. So today we are going to discuss about the Linux file system permissions and how we can manage our files, folder permission, group permission, ownership. These things we are going to concentrate. So today we have another exciting session where we have an implementation as well, where we will cover how we can grant the permission to user, how we can grant the permission to groups, how we can manage multiple nested groups. These things we will discuss, and we will also concentrate on default permission like UMAS. How we can change the default system permissions so that these things will be covered today. So now let us start. You know that the Linux by default they are not providing any execute permission to any files and folders. File permission control access to files. The Linux file permission system is simple but flexible. And you know, the files have three categories of user to which permission apply. The file is owned by user, normally the one who created the file. The file is also owned by single group. So here you can see that we have a two user, Joshua, Ellison. Joshua and Ellison both are the part of web groups. Now two user, they are part of single groups. So how it will be managed? Whether both Joshua and Ellison can read write, or how it will be managed. So today we are going to see how this is going to apply and how we can control if multiple users is sharing the same groups, how we can manage those groups. So here Joshua is a member of web group. Ellison is also a member of wheel and web group. Two groups Ellison is a member. Now, since Joshua and Ellison is like part of same group, so how it will going to apply their permissions? So today we will see all those things, and you know that generally we are managing our permissions, Linux files and permissions using three methods. One is chmod. Chmod command change file permission from the command line. There are two methods to represent file. One is symbolic letters and another is numeric digits. By default, if you want to grant the permission to read level, you can give chmod that u plus r. That r means the user uh, and r read is 4, write is 2, execute is 1. So you can change the ownership as well. For the group members, you want to change the ownership that these polling groups can manage these entire folders and files. You can do. And using -r, you can give recursively change the ownership of a directory tree. You do not have to go to each and every directory and change the permission. You just use -r and it will be granted to all the files and folders inside that folder. And using the umask command is managing the default permission. By default, whenever we are creating files and folders, all these permission is checking the umask value, and the depending upon that value, they are granting the files and folders permissions. So today we have implementation on those things. And R is for read, W is for write, X is for execute. This is the permission. And by default, Linux is not providing execute permission to any files and folders. So you need to grant manually all those permission, and we have to manage all those things. And you know that by default, whenever we are creating a files folder, dash is a regular file, D is a directory, L is a soft link, and other character represent B and C will be the other special purpose file. So let us suppose we have a 4 user operator 1, database 1, database 2, contractor 1. 4 users we have, and they are the part of group members. Operator is operator 1 and consultant 1, two groups. Database is database 1 and consultant 1. Here you can see database and operator 1 both are the part of consultant 1 group. And here you will see database 2. They are part of database 2 and operator 2, two groups. And contractor 1 is the contractor 1 and operator 2. So 2 operator 2 both are nested. Those users will be working the files and directories. So how we will see today, we will like how we can, if multiple users are the same group part of group, their default permission will be how it will be applied. We'll check. And how that changing files and directory permission we can do by ch mode. We can do it either by value or granting by plus or minus, or you can add and remove the permission, and recursively or use equal to replace the entire set of group permission. So chmod is the main command who can changing the files and directory permissions. Apart from that, we do have a chown, 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 that is for ownership. So today we have those implementation on those things. So you can see that chmod is giving the permission to as a read, write, and execute methods, and we can also grant the permission in numeric value. You can see one start with 0, 2 if the read permission should be present to the special level, add 4. If the write permission should be present, add 2. If the execute permission will be add 1. So by default you can see 4 for read, 2 for write, and 1 for execute. By combining this value, we can grant the permission to user. Let us suppose if I am making 4 plus 1 equals to 5. That means read, write value we are giving, execute we are not giving. And if I am combining all the method like 4 plus 2 plus 1, 7, how do I do this? That means the entire set of permissions we are granting. Now we will see. Here you can see that we are changing the ownership of the permission for one file. And here we are giving to entire directory, subdirectory to that particular folder using chown command. And here also, if I want the chown command can be used change both owner and group at the same time, we can change. We can, this is a user, this is a group. Group. So they can, you can change the permission of that ownership of the file using chown command. And you know that when a special permission are those kind of permission in which we want that we want to set some set UID, group UID, sticky bit. So the special permission, if we apply that SUID, file execute as the user that owns the file. So those users who are the owner of the file, they have the execute permission. Other user cannot execute that file. And file execute as the group that owns the file. So if the you are providing is still like a special permission like set UID permission to group, so only those users who are the part of the group can execute that file. The other user cannot execute that. Files newly created at the directory have their own permission. And if you are applying sticky bit means that those users who is having a read write permission to any directory, they can do all those work, but they cannot remove that files. They cannot delete that files. That after sticky bit, your files will be secured. They can do their work operation, but you cannot remove that files and folder whatever if the sticky bit is applied. Only the owner who has put that sticky bit, they are supposed to do any kind of removal permission. So today we will check all those a special permissions as well. And you know that I already told that 4 stands for read, 2 stand for write, 1 stand for execute. Here are the rights 7, 5, 4. Each individual represents the permission to the user, group, and others. So generally, if you want to give the execute permission, so generally we are giving chmod u plus x, group permission g plus x. If you want to remove permission, g minus x. If you want to rewrite, like example, read and write permission, u minus r minus x file. You will give the permission like this. References, if you want to reference by equal to, if you want to change the file permission same as the another file, you can give the equal to permission. So it is equivalent to that file permissions. You can do that. You can recursively add the permission by hyphen r, change the execute permission on those directories and files. So to set up a set GUID, and sticky bit, we have a value as well. Sticky bit, you can provide one before the permission granted, set GUID 2 and set GUID 4. This is the default, and we will also discuss the default permission. Default permission is like you must value the permission by default. It is set to the user. So this is about the read write permissions of all the users. So we have seen like what exactly the sticky bit, what exactly the set UID, set GID, sticky bit. So today let us go for some implementation tasks where we can implement those things whatever we discussed. So let me log in onto one server. See here, I'm telling you. So here you can see we have a user Joshua. We have a user Alice. We have a user operator one, database one, and we have a several groups over here. Database one, wave one, Joshua. So we in earlier session we have already seen that how to create a groups and a user. So today we will concentrate on the files and permissions. So let us, if I am creating a one folder, mkdir slash tmp common, and I am giving by default permissions. You can see here intent common, it is directory file, and it is permission like this. Your owner can do anything, group can read and execute, and others can only execute the files. They cannot read and write all this. So now by default you can see the root is taking the permission of that file. If I want to give the permission to any specific group, so that only that group, let us suppose I am giving the permission to web group, John, I am giving the permission to web group. Just a minute. So now if I will see the permission level over here, see the web is now the owner. Now if I want to give the complete permission to web, user, either user wise or by default I'm taking the user wise also. Now you see that you web is the part of that. Now if I'm logging on Joshua, Joshua is the part of right now operator one group. So now if Joshua wants to do any kind of want to go to that particular group right now and wanted to do some kind of operation, see the permission is denied. Joshua cannot do all those things. They can only read the file. Group membership you can see here, read and execute. You do not have any other permissions right now. Joshua cannot do it. So let us suppose if I am doing modification to Joshua to web group. Now if I will see here, Joshua is the web group members. Now if I want to see whether Joshua can see, now Joshua can create files, and by default Joshua is whatever the files Joshua has created is having read write for owner, and for others group level read permission, other user read permissions. Why? Because here if you can see the default permission of the Joshua is 022, and if I want to change the permission, we can do via umas 0002. Now if I will check the default permission, now here if I Joshua want to do any kind of operation like F1, F2, F3, now you see the changes over here. Earlier when Joshua created the files, by default other users is having read permission only. But now after changing the umask value from 0022 to 002, now Joshua, whenever Joshua is creating a file in that particular directory, they do have a read write permissions to that. So, and by default you see here Joshua is having a bash src folder, that hidden folder. Here he can store umask value. Let us suppose Joshua is giving 0002. So now if see the user value is that Joshua, whenever Joshua create any kind of file, the default permission will be applied from this umask value. So this is the way. Now let us suppose Joshua, now Allison. Here permission is getting denied because the bash profile has been changed and not changed directly to from Allison. No, that's not an issue. Here you will see that by default their permission is 002, and this is the part of operator one group. So whether Joshua Allison can create any files and permission, if he want to go to that same directory, he can view that. Even he cannot read that file because operator one is not the part of that group. He cannot do any kind of operation. So now what I will do, I will change the permission as a mode -g Joshua. I can make the permissions. Now Allison is also the part of wave group. Now let's see whether he got rights or not to temp. He is still not having the rights, but Allison is having the Joshua is having the rights. If he want to go to that directory, he cannot read even the files and folders of that directory because you can see that the group permission is still only that level. Other users cannot do that. Right now, see, he is not the part. No, he is not the part of that web groups. But what exactly happened over here? We can apply the permission to that files so that only the groups, those who are the part of the groups, they can read write those permissions. So how can we do that? I will show you. Chmod -r g plus rwx. So now if I will see here that same directory, see now the permission is read write x. Now if he will go to that directory right now, now he's a part of web group and wanted to go to that directory, still he cannot access the files, but Joshua can access the file. See that whatever the files like he is creating. Here it is getting created here as a part of that group. And now if I will log in via Alison, he can create the files folder, but since he is the part of that particular user, he is also having the part, but he cannot check Joshua files. He can create the files, he can do any kind of operation, and their UMOS value is 022. And if you by default the owner is having the read rights, here Joshua is the owner. Joshua is the part of web group, and Ellison is also part of web group. Both can read write, but they cannot see their files of Joshua, and they cannot, Ellison cannot see their files because they have given the permission and they are working, they say sharing the directory, but they have their ownership on their own files folders. So here you are, if you want to see their bash src folder and all those things, you can also check all those things. So now let us grant some permission. Now what exactly I'm doing here, what exactly we will do, by root we will grant the permission to entire folder. We want to give 777, that means read write execute every permission to that folder to everyone. Now if you see that file, they got populated with all read write permission, right? Now if any user as to Alison wanted to go to that directory, they can see the permission T1, T2. So now if I want to check via other user su-operator one, Alison files, whatever the permissions Alison is giving, their folders is everybody can see, but Joshua permissions, like whatever the Joshua is created, that permissions is not coming here. See, Joshua web, still the ownership is for that particular user. Now since we have given the permission to read write execute, but here the permission you can see here root web, User is root, group is web. So for those users who are part of group, they can do all these things. But ownership, if I will say ch1, so the ownership is got changed, root. Now if anyone want to check the files and will go to that directory, they can do any kind of operation. Joshua can also do, Allison can also do. And if right now Allison will go to that file, and if he want to check that folder, they can check now. They have the permission and their UMass value is 0022. So this is the way, like if users are the part of that group, they can create the permission unless they don't have the entire permission. Now if I will set the permissions like chmod u plus s, that means I'm giving set uid permission to that directory. Now those users who are the part of that particular and created, they do their permission we will see. You see Joshua, ls lrt m common. So here it now y1 y2, their permissions we can set here. If I want to give o plus p y1 and y2, the sticky will be set here. You can see the P permission is coming. For now Joshua only can delete this folder files y and y2. And if I want to set their set uid y1 y2, now you see their set uid is honor. Now only Joshua can execute that file. Other user cannot do that file. Now if I am setting their group id g plus s y1 y2, now see their permissions, only those part who are the group of that file, they can execute. Other user cannot execute that file. So just now if I am giving some commands here, cat e tmp common, So now I'm giving permission, execute permission to y1. So so here now Joshua can execute that file. You can see here. Now, if I am logging out from that user and I want to log in as a general user, operator 1, and I want to go to that directory, I will check that. See, we cannot see all those files, whatever Joshua did, their operations. Even though we have the complete rights, we cannot uh, see all those y1 and y2 files. We cannot do any kind of operations on that because even our group is operator 1. Let us suppose if I am the group of Allison. See, Allison can do all those operations, like whatever that files is a part of that. They cannot do any kind of operation which is the Joshua has done that operation. Only y1 and y2 is not at all visible to other users because they have, although they have the group membership, but user memberships they do not have. This is the user membership and this is group membership. Group membership means that you have a read write. You can do your own work, but you cannot touch any other files and folders to others users. So this is the way we are creating our managing files, folders, and umask value. We can check the ownership of that, anything, whatever the users has created. So here, if whether operation not permitted, why? Because 1, 2, 3, Joshua is the ownership. Allison doesn't have the ownership of that. If he wanted to apply their policy, he can do here in T1 and T2. He can do that. If he want to apply a group membership here, he can do that. Only he's supposed to do the work on his own files and O a plus T. If I will give, see, he is having their rights on their own folder and for files. He cannot touch that. But we have seen, since we have given, and here the umask value you can see here 022. If I want to change the, right now whatever the files we are creating here in that particular directory, F23 or F24, you see that we have owner is having a read write, other is having a read permission. And if I want to change the value to 0, 0, 0, GK2, and if I will create file now, GK1, GK2, you see the difference now. Earlier we group is don't have the read write. Now they have the read write. Group is having the read write. Now earlier you can see that F24, F23 doesn't have a write permission. But here GK and GK2 is having both read write permissions here. So if right now I'm the part of Allison, if I will go via Joshua, and if I will see, GK1 and GK2 is coming right now because we have given the group permissions over here. So if Joshua is also giving the group permission to their files and folder, GK, and let us suppose if Joshua is giving read write permissions, two, one, two, three, we have to set the permissions here. Now 1, 2, 3 is having the permissions of read write. So now you can see that earlier when we log in onto the Allison, that is not visible. 1, 2, 3 is having a read permissions. Now we have granted a write permissions. So if I will go to see 1, 2, 3 is having a read write permissions. So this is the way we can set sticky date, group ID information, and we can manage files and folders to our all Linux file systems. So we need to have the proper understanding of all those things. So today we saw like how we can grant the permission to users, how we can we can create and manage the nested groups, Joshua and Allison. We have given the demonstration of how the files and permission is getting created. We have checked the UMass value. We changed the ownership as well. We have given the read write permission. We create a multiple users and multiple groups. We have checked their soft link, directory, regular files. We also given and granted the permissions. So we need to have the permission like set the proper permission for files and folders in Linux so that the other user can view the read and writes and execute function depending upon their permissions. So I hope this is a proper understanding of Linux file-based system permissions. Thanks for watching. So I'm closing this session right now.